friends, so after understanding the concept of how to solve the higher order differential equation whenever right hand side is e to the power x or the exponential function, let's move to the problem based on the same concept. So here I have a wonderful differential equation, or I would say the higher order differential equation for you all, and we are going to see how to apply those steps in this numerical. So we are going to refer the previous video again and again so that we can get the solution of this equation. So here the question is, solve d cube y by dx cube minus 16 dy by dx is equal to 2 times hyperbolic cos square 2x. Oh, you must be thinking, sir, you are saying that you will be solving the sum which is based on exponential function, and on the right hand side you are showing us the hyperbolic function. So guys, let me tell you that even if it is hyperbolic function, we have the Euler's formula with us, and by which we can convert this hyperbolic function into the exponential function. Here I'm going to use the formula of hyperbolic cos x, which is e to the power x plus e to the power minus x upon 2. So same formula I'll apply for hyperbolic cos 2x. So let's start. So first of all, what I'll do is, on the left hand side, since we have the differential terms, let's replace it by the operator. So we know that dy by dx is denoted by capital D into y. Then d cube y by dx cube is nothing but capital D cube into y. So I'll replace it, and at the same time I'll be applying the Euler's formula on the right hand side. So guys, here we'll get, therefore, d cube y minus 16 Now let's simplify this. So I can take y common. Here 2 square becomes 4. So 2 ones are 2, 2 twos are 4. So I'll get 1 upon 2. And in the bracket, the square of this. So here I'll be applying the formula a plus b the whole square, which is a square plus 2ab plus b square. That will give us so that is the expansion of this bracket. Now guys, here we got the differential equation. Now if you see the left hand side with y, we always have the function of d. So this is my f of d, and I'm going to use it to find out the auxiliary equation. So here I'll say so we have equated this equation to 0. Now let's find out the roots of this. So I can take d common. We'll get d square minus 16 in bracket, which is so here I have applied the formula for d square minus 4 square. D minus 4 and d plus 4. So here we got 3 roots. One is 0. From here we'll get 4, and from here we'll get negative 4. Now guys, all 3 roots are distinct and real. So to find out the yc, we know the solution. So let's find out the yc. So the complementary function therefore is given by c1 e to the power first root, which is 0. Then c2 e to the power second root, that is 4x. And c3 e to the power third root, that is negative 4x. So this is the value of yc. Obviously you can make this e to the power 0x as 1, and that will become only c1. So this is the value of yc, or the complementary function. Now let's find out the yp. So guys, what I'm doing, I'm just following the steps. So these are the steps which we have seen in the previous video. So just now I got the value of yp. Now let's yc. Now let's find out the value of yp, which is particular integral. So the formula is like this, which is 1 upon function of d into e to the power ax. So here I'll say, therefore the particular integral is 1 upon function of d. Now function of d is d cube minus 16d into, we have right hand side. So this is nothing but the right hand side. So let's see what is the right hand side of our question. So guys, this is the right hand side, but since we have simplified it like this, I'll write this function over there. So that will become, now I'll take this 1 upon 2 outside. Now guys, in the bracket there are 3 terms. So 2 terms are exponential here. I'll add e to the power 0, so that will also become exponential term. And I want to apply this operator on the exponential terms. And guys, if you see the rule, then what do we do here is we apply this operator on one exponential term. So what I'm going to do is, here I'm going to apply this operator on each function separately by using the linearity property. So here I'll apply this operator on first e to the power 4x, then plus, then on the second term, then plus, and then on the last term. So that will become, so this is on the first term. Now in the second term we have 2. So I'll write e to the power 0x with that, because e to the power 0x is also equal to 1. So 1 into 2 is 2. So 2 will remain as it is. And then the last term, that is, now let's apply the rule. So the rule says that we have to substitute d equal to a. So a is the power of this e. So here if you see, this value of a is 4. So it means I'm going to put this 4 in f of d. So if I put 4 here, if I substitute here, I'll get 4 cube, which is 64, minus 16 into 4, which is 64. So 64 minus 64 is 0. So since we are getting this denominator as 0, we are going to move ahead to the next rule. So whenever we get this value as 0, what do? We find out a derivative of that f dash of d, and we add x in the numerator. So I'll follow that process. So here I'll say this is equal to 1 upon 2 in bracket. I have added x, and now let's find out the derivative of this term, which is 3d square minus 16. Then this e to the power 4x term as it is. Now let's move to the second term. Here also we'll do the same thing. I will first put this value of a in f of d. So if I put 0 here, 0 cube is 0, minus 16 into 0 is 0. It means again we are getting 0 in the denominator. So the same rule as first term. So here I'll multiply this numerator with x, and in the denominator we'll find out the derivative of this term, which is 3d square minus 16 into e to the power 0x plus. Now the last term, here again the value of negative 4, we'll put it here. Negative 4 cube is negative 64, and this is negative 4 into minus 16 is positive 64. So we will get again 0. So it means again we are getting 0, so we have to find out derivative. So here I'll write x upon, so now let's substitute this value of a in this f dash of d. If I put it, I get 3 into 4 square. 4 square is 16. 16 into 3, 48. 48 minus 16, that is 32. So we'll get 32, and 32 is not 0. So we can use the method. So now guys, see, if you observe one thing, that here we were getting 0, but now as we got the derivative, this derivative is not 0, so we can keep that value as it is. So here I'll get value of yp as 1 upon 2 in bracket x by 32 into e to the power 4x. Let's move to the second term. If I put 0 here, we'll get negative 16. So 2 upon negative 16 is minus 1 by 8. So here, guys, we will get negative x upon 8. Next here, if I put minus 4 here, minus 4 square is 16. 16 3s are 48, minus 16, that is 32. So this is plus x upon 32 into e to the power negative 4x. So guys, here we got the value of yp. So we can simplify it further. So what I'll do is I'll take x upon 32 together. So 1 by 2 as it is, x by 32 common, and bracket will get. So I've taken these two terms together. Then minus x upon 8 as it is. Now these two I'll shift here. So that will become x upon 32 into e to the power 4x plus e to the power negative 4x upon 2 minus, this will become 2 8s are 16, that is x upon 16. Now guys, this is the value of hyperbolic cos 4x. So here we'll get now from this we can take x upon 16 common, and here we will get 1 by 2 into hyperbolic cos 4x, or I would say hyperbolic cos 4x by 2, and from here we will get 1. So guys, this is the value of particular integral. So we got the value of complementary function and particular integral. Now just last step where we will take these two values and we'll add it again. So therefore the final solution or the complete solution, which is y, is given by this complementary function plus particular integral. So guys, what you have to do is you have to copy this value of yp here and this value of yc here, and you'll get the final answer. So this is how we got the solution of the given higher order differential equation, and I'm sure that you understood this method. So guys, keep watching the videos, because in the next video I'm gonna take more numericals on higher order differential equation. And guys, if you want to have the updates about the Ekeeda or the latest videos that we are posting, then you have to subscribe to Ekeeda channel and do share with your friends, because they are also doing the engineering, and if they watch these videos then they can also get the good marks. So thank you very much, keep watching the videos.